Welcome. This session is the NOAA NESDIS Data Technology and Infrastructure session. And I'm going to say some things about what is this session. I'm also going to invite folks to come up and get a delicious, they make them bigger in Texas, donut up here. Just carve yourself off a slice. And throughout this session, there's going to be QR codes up here. And it's a kind of a big room. So if you need to come up to get your phone to see it, if you're at the wrong angle, you're too far away, just feel free to step up and aim your phone at there. That's totally cool. Okay. So hi, I am Jessica Morgan. I am the Assistant Chief Data Officer. You can ask me about that later for the NOAA National Environmental Satellite Data and Information Service. Okay, so we are the duh in NOAA. And as such, I chair with two other co-chairs, the NESDIS Data Management Working Group. We've existed for forever. And our data management working group, the intention is to connect parts of our NESDIS organization, which, like all federal agencies, it's a blob full of blobs. And the blobs, I wouldn't call them silos of excellence, but you get the idea, right? So I have two co-chairs. So John Ralph, wave. And so he's representing the National Centers for Environmental Information, NCEI, also known as the NOAA Archive. And then Tyler Christensen, who unfortunately can't be with us today. So she is the NESDIS Chief Data Architect for the NESDIS Common Cloud Framework. You're going to hear all about all of this in a minute. But so as the co-chairs, we all love ESIP. And at some point last year at an ESDIS session, people were kind of riffing on the NESDIS versus ESDIS. And there's in fact going to be a session this afternoon on NESDIS versus ESDIS and who got to the end first and what is that whole thing. But we were thinking, wait a minute, NESDIS is more than the data archive and it's more that I do policy nonsense, right? We are a whole huge data technology infrastructure engine. And so as co-chairs, we thought, hey, let's, in the spirit of bridging divides, let's bring together our data technologists and our dataists into my favorite data community. So I'm really delighted to pull this together. I'm delighted that we have some folks joining us in the ESIP family for the first time, maybe presenting for the first time. And I'm delighted that we're here. And I want us to do a little show and tell as we do, interactive, of course, but then we'll ask the speakers to come up here and Q&A, and we're going to make sure that questions on Slido are sort of given to the panelists. John will be walking around with a microphone for questions in the room. And remember on Slido, you can upvote questions, okay? So do that. That'll be awesome. Okay, so there's also a welcome poll. So here's the first Slido thing. This is just kind of a get to know who's in the room situation. I'm going to pause here and say throughout the presentations, there will be other questions. Once you're into this Slido, it should advance you to the next set of questions, right? But so everybody get this one on their phones and be ready to participate. And then are there any other, okay, so the outcomes. So NESDIS, we're a federal agency, right? And we have a whole bunch of stakeholders. Our stakeholders are within our agency, right? Particularly Weather Service, but our stakeholders are everyone in this room as well. And a goal that I have is to take the feedback that we get, the notes, the Slido questions, all of that, take that back home to NESDIS HQ and say, hey, here are questions that were asked. Here are conversations that happened. I want to act upon what happens today. So that's a goal that I have. And so I'm very excited to be here. Okay, so generating awareness, discussion. Sometimes y'all might think federal agencies are a black box. We're not. We just you gotta like ask us questions and then we will hold forth. So, and so we have 5 topics with 5 presenters from different bits of our blobs. And we're going to go from like sort of concrete example into data technology infrastructure sort of talks. So we're going to try to take you on a journey. Okay, and so with that, I think we are ready to, okay, here's our host. That was me, John, Tyler. And so, yes, so our first speaker, Courtney, she is with the NOAA archive, so NCEI. And thank you for the donuts.
All right. So like Jessica said, I'm Courtney Bouchard. This is a bigger room than I've ever talked to in my life, but I'm not used to this many people listening to me at once. But I am an oceanographer with NCEI, and I'm going to be talking today on bridging the divide between operational in situ monitoring and historical climatology. So I work on the World Ocean Database, which is we're transitioning into the cloud right now with NCEI, and we're trying to take this opportunity to gather stakeholder requirements, basically. So if you could, while I'm presenting, answer this Slido. You should be able to advance it as you're going along, but I have quite a few questions. And we're trying for World Ocean Database to modernize our code base and get some more with our team of 5. We only have 5 people. We're all oceanographers. None of us are programmers. So we're trying to make sure we're making this effort as efficient as possible with our smaller team. So anyways, the in situ problem, I'm starting at the bottom, like Jessica said, and then we're working our way into the whole larger NCCF infrastructure. But the problem I see as an oceanographer trying to get data and trying to ingest data into our archives is that oceanographic data comes in many shapes and formats. As most of you know, it's hard to take all those heterogeneous data sets and create one similar looking data set. Quality control varies between cruise to cruise and provider to provider. Sometimes within providers, the quality control is not there. And then, there's a growing amount of data with new technologies. I'm going to try this. I don't want to. So this is one of our graphs from I don't know if you can hear me online, sorry. Our graphs from the World Ocean Database from the 1900s to 2024, I think is where it ends off. But you'll see the growing amount of data. And we start with a lot of bottle data. Then we go into the XBT, MDT era. And then after 2000, we can't really see it because I'm in the way, but getting a huge spike in a lot of data. So we're trying to keep up with this spike of data coming in. I don't know if I'm blinding anyone. And then on the access side, which a lot of people have talked about, and there's a lot of solutions for this, but the granularity of the needed subsets of data are different for every user. So every researcher has different depths they want to look at, particular cruises, et cetera, et cetera. So World Ocean Database, my colleagues from way before when I started at NCEI made this database to kind of address all those problems. Our 2 main things were within NCEI. So our main focus is stewardship. So these numbers will be available for life in a format expected. So the raw data, and then science. So we are trying to make this archive usable and reusable in the future. So using the numbers that are true to the Earth system. Basic run through. Raw observations. We get a lot of raw observations from a lot of science partners, a lot of programs like IUS gliders, Argo, NOAA fleets, but we also get a lot of one-off data that come in and or smaller data sets compared to those large databases. So we're working with all kinds of shapes and sizes of data. We do a basic QC, and then we archive them with metadata development. And then from the archive portion, we convert that to our common binary format. We clean it, We do a lot of integrity checks, initial quality control. We eliminate duplicates, do some more statistical analyses, and then QC again, and then we merge it into this big world ocean database. This was our first year. We have over 20 million ocean profiles. It's a lot. And then the data is continuously added. So we're always adding data. This is like most of what we're doing day in to day out is getting this data merged with our database. And then we do quarterly public releases. This is considered a foundational database. And then we also have downstream data sets that are products that we create in-house that are useful and could be very useful for the community. And government users, commercial users, those kind of people are the blue economy folks. The Navy uses our data, that kind of stuff. So, can't see my notes, so I think I covered everything I wanted to cover. Okay, so this is I wanted to include this slide. Obviously, I already said we archive the data, but this is how we keep this database transparent. We give an accession number, which is what we call that at NCEI, an accession number for each data set that comes in. We give it an accession number, which identifies its place within our archive. And then, and that's just the raw data. That's not anything we have processed through WOD. So you can always access our archives using these accession number links if you want the like pure raw data from that. So yeah, so this just keeps us transparent, and since we're NCEI, it's very important to keep our archives available. But the thing that World Ocean Database does is it adds value to the data because we are doing so much of these QC checks. So like I said, it's kind of I've already been through this, but our initial checks are looking for self-duplicates, location dates, anything like initial scientific checks, whether the data is valid or not. Then we go through in uniqueness. Sometimes we get data sets that are already in World Ocean Database from whatever provider is providing it. So we make sure that we're not, adding duplicates of the data. We do platform consistency with the metadata across platforms. And then do we have the CTD data? Now we have bottle data so that we can QC that together and create flags or throw out any possible bad data values. And then, so QC'd, properly flagged data, and then we give it cruise numbers and station numbers, and then we merge it into the WOD file. And it's used to create some of our downstream products, like I talked about, the World Ocean Atlas, regional ocean climatologies, which brings it in situ. It's all in situ, by the way. I don't know if I mentioned that. All in situ data down to the 10th degree. So a lot of modelers can use that as an in situ check, I guess, on their models. And then we also create the ocean heat content, which is one of our more popular downstream products. And those go through even more additional QC from our team. And so if it isn't obvious, I'm asking the questions on the Slido if you've looked at them, because we have this team of 5 and this is a lot of work to do. And so we want to be able to do it as efficiently as possible and make sure we're actually meeting the needs of the community. So please answer those. I'm going to plug it again. And then this is how we address the access side. So we have this platform, World Ocean Database Select, is a little bit dated. No offense to my amazing colleagues who created it. But yeah, so it's very, it'll email you the data set. So you can go through and you can grab our data at the deepest measurement you want. You can grab the specific types of data, all that stuff. You can pick your own parameters because we are just pulling it out of our database after we've already done all of the ingest load of getting it all into one format. So then we can actually do like the chunking and the gridding and stuff. And so after hearing some of the talks, I am very interested in talking to some people more about different ways of accessing this. But this way of accessing is not scrapable by LLMs or any AI agents, I don't think, unless they have an email and a person on the other side. So it'd be nice to maybe talk more about that without bogging down our system with requests in the future. So please talk to me. And then this is what I am also a hypoxia research, so I like to sneak hypoxia into every presentation I give because I want to still be a hypoxia researcher. But anyway, so one of my other products is the Hypoxia Watch, and I wanted to highlight how this World Ocean Database and ocean observations are shaking hands. This is the Oregon 2. We are mandated by the HABs and Hypoxia Research Control Act to monitor hypoxia within NOAA. And there is an annual cruise that goes out, and it's been monitoring it since the 80s. But this Hypoxia Watch is in near real time. So we're getting all this data set in real time, and we're also we're doing our own QC, making our own maps, passing that CTD data into our archives, and then they make their way into the World Ocean Database, and they become climatologies, which then eventually the researchers the next year can use to see where they should go, because hypoxia is a very dynamic phenomenon. So it's not always in the same place. It's not always the same size, severity, blah, blah, blah. But yeah, and then we also merge CTDs back from the World Ocean Database back into quality control, our Hypoxia Watch maps as well. So it's kind of circular, and I think, it's a pretty practical use for that. Oh, there's my time. All right. So that's the end. So it's perfect. It's you guys. Thanks. Any questions? I don't know if I have time or if we're just doing it at the end. I know I went really fast, so honestly, please come and talk to me about World Ocean Database. I need to hear more about how we can make it more modern.
Hi, I'm Eli Holmes with NOAA Fisheries, and I was wondering if you could talk a little more about that, kind of the QC step and what's involved. I think that's like a really important value added part of the data. And so if you could talk a little bit about that, and then also talk about do you also do QC on, or are planning QC on, well, I'm using mainly NetCDF files, and that's something I run into a lot, is I think the structure of the files maybe hasn't been QC'd really well.
From World Ocean Database, you're saying?
No, not from World Ocean. Just in general. I'm just wondering, but for World Ocean Database, is that something you QC?
I see. So the metadata structure of it, what standards we're using on. Okay.
What is this? Yeah. What does this QC process really look like? What are the kinds of things you're QCing?
Yeah. So basically everything on this slide. So when we do an initial check before we even archive it of self-duplicates, are the location and dates, do they make sense with what's being described? Those kind of things. And those are all done with various Fortran programs. The database is mostly in Fortran right now, and we are using this. Yeah, don't laugh. It's very robust. But we are, we're losing Fortran knowledge in the community. So we are, part of what we're trying to do with this modernization effort is to change our code bases. So, but yeah, for the QC part, sorry, the QC part. And then we're also checking for, checking the variables to see if it's CF compliant. CF 1.6 compliant for our NetCDF specifically. And our flags are WOD specific. So we use those QC flags, and we have them described in some technical documents to go along with it. And I don't think I'm not sure if I fully answered your question, but yeah, we go through several steps. So before the archive, we're QCing basic stuff. Then when we're merging the profiles, we're seeing if things are inverted on accident. And a lot of it is manual. A lot of it is we run the program, and then we're looking through them as a group of 5 people. And then we put it in, merge it with the files, and then the downstream products are very manually QC'd. We are going through and looking for bullseyes. When we create the climatologies, we call them bullseyes, where it's like, that's clearly not a real feature kind of thing. And it's manual. And so we'll go through and look at each profile that is flagged as a bullseye, and we'll see, is there a problem at a certain level, depth, that it, the optimal interpolation, didn't really interpolate that well, kind of stuff. So that's kind of an answer. Oh, hi.
Hi, thanks for your talk. I'm Steve Young, former EPA. You mentioned that you assign accession numbers.
Yeah.
Do you do DOIs also, or are those translatable to DOIs, or?
Usually, yeah. Like John said, I'm looking at John so we create the accession numbers on the World Ocean Database side, and then the DSD, so John's group, will assign a DOI, or the intention is to assign a DOI for each one.
Yeah,
right?
John Ralph, NCEI. Yeah.
What did I say? What did I call you?
I'm just announcing myself.
Oh, okay.
As one is supposed to do. Yeah, we changed our policy recently, so almost every archive package accession with an accession number gets a DOI by default, unless there's a reason it should not.
What, for example, what would you?
You asked.
Sometimes they are parts of larger collections, and so the individual data sets that are part of these larger collections don't get an individual DOI. Instead, you get the DOI of the collection itself. Yeah. Mm-hmm. So there are reasons, and there's policy, and blah blah blah.
Yeah. So we're really, with the data providers, we work really closely with them. So if you want to contribute any data, let me know. Thanks, y'all.
Hi, everybody. My name is Brian Meyer. I am with NCEI as well. And I am going to be talking about how we are folding in our legacy marine data into our satellite-focused NESDIS cloud enterprise. So real quick, if you have a moment to go to the Slido, essentially I'm asking you all what I should talk about, because there's 4 sort of components to my talk, and I want to make sure I spend the majority of the time talking about the components that you all are interested in. So awesome. I'll just monitor that. So just to give you guys the brief of what I'm going to be talking about, is I am going to be talking primarily about what I call cruise-based data. This doesn't necessarily mean a ship. It can be any sort of event-driven data set. It could be an ROV deployment, a wave glider, a airplane, but for my purposes, it's a cruise. So, and just how that differs from satellite and station data. How do we translate those requirements into cloud data management capabilities? So cruise-based data is highly variable between collections, and the way that these data are discovered and accessed are quite different from satellite data. And the base NCEI data management structure is built for highly normalized data sets, because satellites spend a lot of time upfront in their life cycle in developing very robust data management plans, naming conventions. You're only getting data from a single sort of source and all that. And so what we need to do is take those constraints and apply them to this highly variable data set. So the analogy I tend to use is a square peg in a round hole. Cruise-based data has a lot of edge cases. We are dealing with humans in the loop, and humans make mistakes, and things need to be corrected, and things get submitted asynchronously, and there's a lot more metadata context that is often needed for a cruise than for a satellite data. So when you are designing a very basic, or maybe basic's the wrong word, but a very normalized data management tool, these edge cases can sometimes fall away and become unsupported. So our goal is to leverage the incredible scalability, cost optimization, interconnectivity, provenance tracking, all the wonderful things that the NCCF is doing, and apply them to the cruise-based data so that we can actually get much more value out of this long-running data set as possible. So the biggest thing I am optimistic about when it comes to the NCCF is this concept of a knowledge graph. And so one of the things that we're running into in the satellite-focused data management structure is there is a limited amount of information we are passing in sort of this prefix structure, which in the cloud is a directory structure on-prem. And there are heavy constraints put on those, the number of prefixes we're allowed to have, as well as the fact that it expects the metadata to be embedded within each data file or file name. But for those who've worked with cruise or event-based data, a lot of times that metadata is external to the files themselves, and so it needs to be passed along and stored at a higher level than the individual granule level. And for cruise-based data, each platform and instrument is considered a collection. So for Trackline Geophysics, the cruise database that I work with, we are talking about several thousand collections that need to be all discoverable and accessed in the same way, simultaneously, subset it, and all that. So we can't just put everything in a bucket and have someone just crawl through that. So and then this is the example of the graph database, which we're really hoping to be able to map the many variables that a data set collects over a single cruise, which could be 10 plus variables. A ship goes out with a large number of instruments on it, and those instruments can be relatively independent or highly dependent upon one another. And so we've had hundreds of providers over the 50 plus years of NOAA's stewardship of these data sets, and the observing conditions change constantly. The systems are changing constantly. The collection processing volumes have changed. The software has changed. The data formats have changed. Even going from paper records to punch cards to tape to digital and now to the cloud. So we are dealing with a large heterogeneity in our data volumes that we need to be able to handle in enterprise data services, which is a tough challenge in the best of circumstances. And so really, and focusing on all those heterogeneities and just focusing on our end users and how they're going to be able to use the data once it's all made it into the cloud. So these are just some of our data access concerns. So here are our solutions. We do a lot of work. It's very manual. It's very bespoke to individual data providers to do pre-ingest data management to normalize these data packages as much as possible. So these are things that we will almost never be able to fully automate. But things change. Someone will submit a data package later from an original submission that we need to update the metadata, we need to update the archive package. And so with satellite data and other things, it comes in, and for the most part, it's unchanged. And for cruise-based data, we have to change this over and over and over again. There's a lot of hands-on work that needs to happen. And so we need this continued reliance on these custom access and delivery tools to support that. And then, of course, there's non-public data. So a ship will go out, collect something that might be PII or a shipwreck or something like that, and that needs to remain non-public forever. Or there's something that might be embargoed until a paper is published, and it will only be non-public for a time. So again, we need to be able to update that metadata back and forth and handle that data propriety appropriately. So our vision is to create a comprehensive cruise catalog. So right now, NCEI is 4 data centers in a trench coat. And so a ship will go out and it will collect some ocean profile data, and that might go to our Asheville archive, and that it will also collect bathymetry data, and that will go to our Colorado archive. But in order to get the most out of both of those data sets, it would be helpful for scientists to look at them together and not have to go to separate data portals to discover and access them. So we want to use this knowledge graph concept so that a computer or a person can look and see all of those related data sets appropriately, access them, and then do their science on them and not have to know independently that these sit in different data sets. And we can, people can ask more just plain language queries of the knowledge graph of what else do I know? Can you recommend other data sets that might be helpful, kind of work that we're trying to support. So, and these data volumes are getting huge over time. My trackline geophysics data set, when I started 15 years ago, the whole database was tens of gigabytes, and now it's tens of terabytes, and that's only getting larger as we go. So we need the scalability of the cloud, and we need this interoperability of the knowledge graph that our relational databases just don't have. And so we are very actively working together with the NCCF developers to add a lot of these capabilities, and we are trending in a very positive direction to be able to do this. But I just wanted to spend my time here to highlight some of these unique constraints that these cruise-based events, the big O in NOAA, not everything comes from a satellite, and we need to be able to build in that flexibility to our system. So thank you.
So, and maybe this is a question to the room. Catalogs come up a lot. And when you're talking about building a catalog for data discovery for this resource, how do you imagine that connecting, or I don't know if interoperating is the right word, to other catalogs to aid data discoverability for other resources too? Is that something you're thinking about? Is that in scope? Are there other people thinking about mega catalogs? Just kind of curious. And then also maybe define what you mean by catalog. I guess I didn't, but like it's a little vague right now. Yeah, 30 seconds, go.
For me, what I define as a catalog is a queryable list of available data sets. So, and what the relationship to other data sets is. So for the cruise catalog, you can query it in a number of different directions, where you could say, give me all of the cruises that have side scan sonar. Or you could say, I have a cruise survey ID, give me all the data sets that fall under that cruise ID. Or I'm looking for all the data in this geographic bounding box, show me everything that's there. And, based on the directionality of that query, you'll get the appropriate listing of available granules. So, and then as far as a mega catalog, that's again one of the incredible things about the Open Information Stewardship Service, which I think they'll talk about, is this concept of a knowledge graph is scalable. So you can go from that granular level to that collection level, to collections of collections, to collections of and you can nest them and build out those highly complex relationships in a, I didn't use the word semantic, but because it's a scary word, but in a semantic way, so that we're all operating with the same understanding of what those relationships are. So I hope that answered your question. Great.
Okay, hello everyone. I'm GM Villanil Otero from NESDIS Office of Common Services, the Product Management Division. And I'm going to be talking here about a different type of data. I'm not going to be talking about data files or data format, but I'm more going to talk about the data that we use in project management, particularly as we track a specific life cycle. We're in an organization, and I don't know how this might relate to all of you, but we're in an organization that has multiple divisions. We have Office of Common Services, we have the Office of Satellite and Product Operations, we have STAR, we have NCEI, and all of us are working towards pretty much the same goal, being distribute data to the users, or make sure that the products that are being generated, the users are able to use them correctly. And by users, it could be National Weather Service, it could be any of us. So I have a Slido link on this page. You're only going to see the QR code for the first 2 slides, and I apologize for that. After that, there's going to be multiple questions. Don't close the web page after you answer the question. You can refresh the Slido, and you will be seeing more questions as the presentation goes on. And don't worry, I will cue you guys when the new questions are going to pop up. So what are we going to be discussing today? We're going to be talking about removing black boxes. Again, we have multiple organizations that each have a specific mission, but we are doing our independent things towards a shared common goal. So let's remove those black boxes. Also, a shared lifecycle view. How can we do this project management in a way that we all can see the status of things? And then the lessons learned of using this. So let me see if the first page has ended. Let's see. Do I need to answer my own question? I do have to answer my own question. Okay. Learning as we go. Okay, so very quick. This is a simple transition to operations or T2O process for those that don't know it. And as we went through this, I was asking how many people are familiar with Jira, and a lot of people use it regularly. So this is great because I don't have to spend too much time explaining what Jira is. But for the benefit of those that don't, I'm just going to answer it very quickly. Jira is just a project management tool and like issue tracking to see how long they take to be done, and et cetera, et cetera. Okay, so back to the simple T2O process. This is a very complicated process that we do here, but I'm just tailoring it to just 4 boxes. We have funding, that multiple organizations provide the funding. LEO, GEO, OCS, multiple organizations can provide the funding. This funding goes to the science teams, such as STAR. Then those science teams give OCS those codes so that we can get it ready for operations, remove any bugs, make sure that it's compatible with whatever tool is being used in the NCCF or whatever framework is going to use. And lastly, we deliver it to OSPO so that they implement it into operations, run it in operations, and maintain it. So the colors are going to be important because we are multiple organizations, again, involved in this T2O process. And if we convert this into how it looks in our Jira environment right now, we have this. So each color is related to the previous slide. So you can see how funding, it involves 3 different Jira projects. You have another Jira project for OCS. You have a completely different Jira project for stuff that OSPO is doing. So in total, we have around 5 different projects involved in just one entire T2O lifecycle. And the workflow only tells you if something is in the backlog, if it's in progress, if it's in review, if it's done. So what that happens? Well, STAR is working on something, and we don't know what the progress is. We're working on something, and OSPO doesn't know how far along we are, which requires multiple meetings, multiple interactions. And the problem with this is that at the same time, it creates multiple sources of truth. OSPO might be working on something. They have their own delivery schedule. We might be working on something. We have our own schedule. So how can we use Jira to bridge this gap? Well, we can remove those black boxes. We can combine all of that into just a single Jira project, which means that one project will contain the entire full deliverable or a release. of an algorithm, a product, whatever you call it, and we are able to track it from, is this going to get funded? Did it receive funding? What specifically got funded to be done in that project? What work the scientists are doing with it? When are we expecting to receive it? When are we going to deliver it? Is it already in operations? What version is it in operations? So many questions that could be answered and have more visibility if it was just in one single project. So this is the goal that I'm working on right now, is consolidating this into a way that makes sense. Let me see. I think we can refresh the page. There's already another question, and I'm sorry if I forgot to remind everyone. So thank you, everyone, for those that are on Slido answering them. So this is the shared lifecycle view that I want to implement, or that I'm hoping to implement in collaboration with everyone. And this way is just, it's the entire deliverable. We're able to know exactly what is happening with it. Is it being planned? Is it in development? Is it being verified? Where exactly it's being implemented? And what this does is that it allows us to have one source of truth. Having everything in one Jira project means that we have one source of truth, and now each different organization can just simply filter. They can use different quick views. We can use automation to, as things move through the workflow, be assigned to certain people. And this makes it so that there's better ownership of specific stages in this D2O lifecycle. So I want to provide an example of the how this will look in Jira. This is in Jira, and we have what we call a capabilities board. Capabilities are what we're calling a deliverable. So in this case, as you can see on the screen, we have a transition enterprise wins version 1 CCAP. We have a transition serial wins version 1 CCAP, and CCAP stands for Cloud Containerized Algorithm Package. It's not really important for the point of this discussion, but we are able to track exactly those deliverables where they are. So you can see that we are currently, one is in development, another one is in UAT, so it's in user acceptance testing, so it's being evaluated by the users. And we can see, everyone can go to this page and be able to see, oh, I'm interested in this product, and I know exactly where it is in the lifecycle. Okay. There's a new question on Slido for those that are keeping track, so feel free to go to it. And I think this one is the most important for me because it speaks as to how much granularity there is in following this lifecycle. But here's more examples on using Jira. So we can track releases. Each product can have multiple versions. We can track which one is it's already in operations, which version has already been superseded by a new version, or which version is not released. And also we can have planning fields, which has the specific dates throughout the entire lifecycle. When the science code is expected to be delivered, sorry about that, when it is expected to be delivered to OSPO, when it's expected to be delivered to implemented in operations. So everything that we might want to know about a single product is all going to be in one space. Let's then going back to the lessons learned. Communication is key. We are multiple organizations. I've mentioned this multiple times. We need to communicate with one another in order to know where things are going. Everyone has a part to play. If no one takes ownership of their part in this workflow, then this all fails. So we need to make sure that we are working together towards this. The main con that I've noticed when doing this is that it requires more admin privileges, because we're doing so many things on the back end, like using Jira in this way. It requires a little bit more technical knowledge of the people that are knowledgeable about how to set Jira up. And the one thing is that there's going to be more future updates that will enable more things, such as GitLab implementation. So this is just the beginning. But my takeaway here is that as we work in this new version, in this new workflow that I'm trying to implement, it will enable us to be more aware of how long things take to get to operations, which will improve the forecasting of future deliverables. Did it take 1 year? Did it take 6 months? And this allows the users to know when they can expect a new version, what is coming in that new version. So it's all data related, but this is a different way of looking at that data. And lastly, the collaboration and communication leads to a better framework. Again, one source of truth. Everyone has a part to play. And with that, thank you very much. And I'll take any questions that you all may have.
Hi, I'm Courtney Bouchard. I work with you. Well, I work at NCEI. But you had on your last slide, I think, the GitLab implementation as that one as phase 2. What does that mean with Jira? Are you working together with Jira and GitLab?
You can make Jira and GitLab work together, which means that what this implementation would do is that you have a merge request, for example, in GitLab, and it would show in a Jira ticket. Once that merge request gets accepted, so it merges into the main code, the ticket in Jira will automatically be closed, will be moved to done. So multiple things that you can improve in
Matthew Biddle, NOAA Integrated Ocean Observing System Office. As you've rolled out a new system for tracking, how is acceptance across the organization been for using a new system like this? And I know there's technical hurdles with adopting something new like that. So,
yes, good question. We're currently using Jira. As I'm just trying to consolidate it into a better use of Jira. As with everything, there is always a little bit of pushback. So that's why the best way is to present like a pilot project of like, hey, this is how it's going to look, and start getting.
Okay, glad to see many familiar faces and new friends in this room. I'm Jay Su from NOAA NESDIS ACIO. My topic today will be from policy to platform to product, building AI capacity at NESDIS. And if you have a good site, you can see here, I say assisted by Gemini. Let's recall how we get here. So if you are old enough, 20 years ago, we have the first modern cloud. And 15 years ago, the government started to think if we need to move our data to cloud. And guess how long it took to make the decision? Almost 5 years, right? And 9 years ago, the fundamental paper about LLM was published. Nobody knows that. In their community, we know that. Anyway, and 3.5 years ago, ChatGPT was released, and different from the cloud case, we immediately know we have no option here. We have to use generative AI immediately. Okay. I'm going to talk 3 pillars. Oh, I need to stay here. Okay. 3 pillars at NOAA or NESDIS. We have policy, we have platform, we have product. So at the policy level, I will focus on the NOAA Generative AI Working Group. For the platform, I will introduce you the NESDIS Jupyter Hub. And for the product, I will talk about Storefront. So think them like a playground. The policy tells us what can bring into play, and the platform created a sandbox, and then toddlers can build castle there, or scientists, you know. For the enterprise governments, we have so many different levels, starting from White House executive orders, OMB memos, DOC policies, NIST, what's a risk management framework. And so at the NOAA level, we need to make sure our pilot projects and the use cases comply with all these things. So the thing we emphasize is usually you need to be open and public data, and the tools you're using should be FedRAMPed, and usually no PII or CUI was involved. And we're being lucky with we're working closely with the leaderships, including NOAA CDO and ACDOs, CTOs and security experts, and NOAA AI Executive Committee, NOAA Center for AI. So we work together to help booster the AI projects in NOAA, and in my case, in NESDIS. The one example, the platform example is NESDIS Jupyter Hub. At NESDIS ACIO, we do provide another platform called NESDIS Innovation Hub, so which is especially for AI projects in AWS. For the Jupyter Hub, if you ever use Jupyter notebooks, if you need to work on the flight to Texas, you better use your local laptop. If you're a secret agent, you need to destroy your script automatically in 24 hours, use Colab. If you are very familiar with AWS or Google, whatever, Microsoft, and you're not super care about the cost, SageMaker AI Studio is a good place to go. But if you're none of them, and maybe Jupyter Hub is the right option. NOAA Fisheries has been working with OpenScapes for many years. They have monthly or bi-weekly workshops. To make it further, NESDIS want to keep the persistent in home environment for every user. And if you want to work with Python, R, Fortran, you name it, you can do that. That's the options for for the user. We have dozens of them, but I just list 4 of them. You can see the users have different options of CPUs and GPUs. And also, you can ask us to pre-install the libraries for you, or you can install the libraries for yourself, and they will be there for the next time you log in. And it's in the cloud, so you don't have to download data if the data already in cloud. For the product example, in NESDIS, we have more than 30 disconnected sites, more than 25 APIs in different data formats, and 75% of users reported not very happy with this. Let's go to search engine. So many hours was lost. Sorry about that. Was wasted, and we need a solution. That's a NESDIS storefront. That's the landing page for the storefront. You can see it's a single point for all NESDIS data, but actually it also have some NOAA data, and also for NASA and USGS. I'm not saying so because I saw some NASA USGS people in this room. It has unified API across all data ponds or lakes, and it normalized data. I will show more in the next slide. And yeah. For the architecture, it's starting from more than 100 endpoints, APIs, and through a series of processing, we call it the medallion structure, from bronze, silver, gold, and finally it's ready for the AI layer. And after that it goes to the natural language dashboard I just showed you. a little more about the AI layer. AI layer. So we are not only using one tool. So when a query comes in, we use it's automatically classified based on its complexity and cost. And we use AWS Titan to convert the unstructured text into structured vectors. And we use NESDIS, which is a specialized model, can understand different domains of science, including earth science. Then we put them together and let the query run through the workflow and give the result for the users. And you can see here's a quote from President Johnson, whose library is right on this campus. I'm lucky visited there yesterday because it's open until 9 o'clock for Wednesday only. So this is when President Johnson proposed to create a new agency called, not agency, administration called ESSC. I remember that a couple of minutes ago, but 5 years later, it became NOAA. So we should thank him for this. And I will thank you guys here and happy to answer any questions later. Thank you.
Hey, good morning, Jay. Jimmy Sanchez. I am the platform. Yeah, right here.
Oh, yeah.
Yeah, Jimmy Sanchez. I'm the platform manager for NASA's NESDIS, the original NESDIS. That's claws coming out. So you talked about FedRAMP. You talked about some of the security controls and the guardrails, and that's some of the same hurdles that we're facing. On the platform side, we have, you mentioned all the executive orders and FedRAMP and those things. We're having to, take those into account. But also then we have the science community that want to run full steam ahead with all the new hot stuff that comes out. Sometimes it's not FedRAMP, sometimes it's not approved. What are you doing to find that happy medium so that we are not slowing down science or progress?
So you can always use your personal computer, do anything you like, but make sure no PII, CUI involved. So that's your playground. You make sure everything runs and you get funding from your agency. Then you can run in the government environment. I don't accept any Jupyter Hub question from Eli.
It's not a question. It's a comment. Hey,
Yeah,
Jay, great
you
to
know
see
the answer.
You've
Yeah.
made some progress on that. For those who are interested in Jupyter Hubs, I'm part of a sort of a group community of Jupyter Hub administrators. I am an administrator for the one we have at NOAA Fisheries for our training. And this is a community of administrators across mainly NASA. And so it's a lot of NASA folks because NASA has a lot of these, but also some groups outside of NASA. Some of these are managed by 2I2C, which does a lot of universities and federal agencies. And then others, like at NASA, they manage some of them in-house. And we use it at NOAA Fisheries for our training. So we do a lot of training in cloud computing and machine learning and geospatial. We want people to drop in and just be able to do whatever they need to do and grab whatever compute they need. If they're going to need GPUs, they can grab that. If they need a big machine, they can grab that. They can do parallelized stuff super easy. Most of the time people aren't doing that, but they drop into an environment. And for us, like a big thing is the cost control. So to provide this for whoever needs it across NOAA Fisheries for their training, it is for training. It's not for operations because just the way it's set up. Hundreds, and it costs us, $1,500 a month for everything. That includes all the administration, which is handled by 2A2C, all the storage, all the compute, everything. And this, again, for whoever needs it across NOAA Fisheries, hundreds will use this. So the pricing can be very economical.
Yeah, that's a good point. We did get some credit from AWS, so we can burn out. And in the future, there's different program officers interested, such as CCF. So funding is big issue, especially for GPU use. So we plan to set a limit on GPU use, and for CPU, it's almost nothing compared to GPU, so that's fine.
My name is Angela Brown. I am from NOAA, NESDIS, Office of Common Services in the Cloud Management Branch. My role there is a data architect, but I am a certified enterprise architect. And so I'm going to be speaking to you from an IT perspective, right? How we view things. Okay, so what I'm going to be discussing really is the data technology and infrastructure piece of it all. So I want to give a perspective from an enterprise view, right? And so we're going to unveil some of the size, complexity, and scope of information engineering, okay? So in this session, we will be talking about standards, life cycle processes and best practices, doing strategy planning of your IT and data systems. So IT strategy planning and solutioning should not just be from one particular scope. I think that Jen spoke about that, right? That we cross boundaries. And so I would just like to share that when we look across the board and we are able to have some cost savings, right? And benefiting like all of the organizations and not just our particular perspective. So typically we look at Scrum planning, right? We look at our particular, what we have to do to get the job done, right? But I just submit to you that with Scrum planning, it's more of an operational and tactical perspective that you look at. And it's driven by mission sometimes. It's aligned with functional capabilities, but maybe not business capabilities. And the enterprise planning or the strategic planning is really done PI by PI. But if you look at it from an enterprise strategy planning, you want to look at the big picture, as I said. You want to look at the enterprise and the core capabilities of the business. And you want to look across not just agencies, but across the government, because there are some core business functionalities that cross different agencies. And I'm going to show you an example of that. So the foundation of enterprise planning is, of course, your people, processes, your technology, your data, and your metadata. So when conducting strategy planning or strategic planning, you must consider the future state, and the current state, and the future state of your people, processes, technology, data, and metadata. Other considerations to consider are your inputs, outputs, controls, and mechanisms of your current and future state. And I'm going to focus on controls here. So I'm going to ask the question while we get there. Okay. And the first person that answers the question correctly, you get a prize. Okay. All right. How much does the U.S. federal government spend on information technology investments annually? Does anybody have an idea? How much does the U.S. federal government spend on information technology investments? That includes data, all of the things, right? Annually. Is it? It's live? Okay, well, how come I can't see? Oh, I got to join. Oh, okay, so then I can see it. Okay, I guess I don't see it. Okay, so the answer is between 100 billion and 400 billion annually. Okay. All right. So why is that important? Besides that, we are all taxpayers here and we want to be fiscally responsible, I hope, with our federal dollars. Think of, I mean, do you think that all of these investments are unique? No, right? There are some commonalities, right? Within your organization and across the federal government. So, but unless you check, you will never know if there are other organizations that you can glean information from, either processes or technology, infrastructure that you can share, enterprise licenses and things of that nature, okay? I said I wanted to really focus on controls because controls are the place to help us make acquisition decisions before we invest in new systems. And there are tools such as EA Sparks, System Architect, and Cameo, as well as frameworks that can help us sort of use our knowledge base to make these decisions from an enterprise strategy planning perspective. Okay, so wait, before we go there, there's another Slido. Did it come up? Okay, I don't have it. Oh, here we go. Okay. Have you ever used an enterprise architecture framework for strategy planning? Yes or no? Okay, what's the answer? I don't see. 10. Okay, 83% said no. So why is that important? Let's talk about that. And I thought that, and I was like, yeah, okay. So why is that important? Let's go to slide 7. There are laws, policies, and frameworks to help enterprise strategy planning. 2 of the laws that I want to mention are the 40 U.S.C. Subtitle 3, which talks about information resource management and how to handle that. The Klinger-Cohen Act of 1996, which fundamentally overhauled how the federal government secures, uses, acquires, evaluates, and disposes of information technology. And these information resource management controls will help us to support the agency's mission and vision, as well as save money, hopefully. Okay, so some of the key provisions here is that the Klinger-Cohen Act aligns IT business with strategy. It optimizes resources to prevent redundant technology and purchases. I was going to use this, but I don't know. I'm too nervous. Okay. Improve decision making, right? So it's used to establish data and architecture models to make confident strategic decisions in your investments. It ensures compliance. Using regulatory requirements that I mentioned, those are only 2 laws that we must align with. And it also creates a common understanding. Now, some of these key benefits are we work with every day, like capital planning and investment control. Any of you guys? No? Okay. your NIT standards, right? Your security standards, right? That falls under the Klinger-Cohen Act. And so this kind of what I'm trying to communicate to you is that this is the reason why we do some of those things, okay? Because there are laws and rules and regulations that say we are supposed to do them. Okay. 1 minute. Okay. So, 4 key provisions that I want to point out is acquisition reform, again, capital planning and investment control, and multi-agency guidance, which is really, really important because, again, we want to share investments so that we can save money if possible. And it also made provisions to have a chief information officer for each agency. So prior to the Klinger-Cohen Act, CIOs weren't in existence, okay? So that's why it's important. And so enterprise architecture, again, it matters because it helps with strategic planning from a strategy level, right? Not just operational and tactical that we do in our Scrum planning, but an overall view of our information technology assets. Also, it matters because it drives alignment across the agencies and across the government. It reduces costs and reduces silos as well as minimize risk. Real quick, these are some of the core domains in the enterprise architecture: business architecture, data, application, and technology. I'm running out of time. Okay, this is a federal enterprise architecture here. This is just, I had another Slido that I don't think we have time for, but there are many different frameworks. There's TOGAF, there's DODAF, there's FEAF, et cetera, right? You just pick one that works with you, works for your organization. And I wanted to show an enterprise perspective, like what does this enterprise architecture look like? Okay, if you can see here in the middle, I was going to point, where the mapping, geospatial, and elevation GPS enterprise services, you can see the agencies at the top that utilize those services. And I would add NOAA there as well as NASA and a couple other agencies, right? Use geospatial and mapping. So they probably have some information technology that we can share, resources that we can share, and et cetera. Okay. And my last slide, I think I had another question, but I can't remember. The last slide is enterprise architecture is many things. I just wanted to share that with you. These are some of the sort of things that you have to develop to have a clear understanding of your current state and your future state as it relates to your IT investments and helps with also your transition planning to the future state. Okay, I think my time is up.
Awesome talk, Angela. You mentioned, shared services between agencies so that we're not reinventing the wheels and that we're not spitting, other than ESIP, how do we find out about those opportunities?
Okay, so I'm glad you asked. Your capital planning and investment control group is supposed to have a list of investments. Your chief information office is supposed to have a list of investments. And they also have access. We all have access. I had the URL somewhere. I'll get that to you. Where you can look up each agency's IT investments, and it shows the dollar amount, it shows the business functionality, and so you can do a crosswalk to see, USGS does the same thing, or maybe I need to talk to them about how we can get an enterprise license instead of having all of these separate licenses and such and such. Okay, did I answer your question? One thing I have to say, with strategy planning, you have to have executive sponsorship. You have to have your ACIO, your CIPIC, your budget, of course, your information technologist, and I'm missing somebody else, but all of them have to work together to come up with this plan. And I want to say that so often it's left to the operational and tactical people when it really should be the strategy people doing that type of work. Okay.
Thanks. We have a question for the group from online. This is Dave Jones asks, how can we share our work funded by NESDIS LEO with other parts of NESDIS to see if there are additional areas where we can work? And I think we meaning Dave's company.
Is that for me?
It's for,
this is for
the entire panel.
Okay. Well, I'll start. Like I said, your CIPIC group, your capital planning and investment control, they are supposed to know all of the application systems and support services that your organization has, right? And so you can start there and in your CIO office.
Oh, yeah. GM Villanil Otero here from, again, the Product Management Division. If you are being funded by Leo, and this is a product that might be funded to go into operations, we have the Product Management branch. They have different portfolios, and they would be the point of contact, in my opinion, to help you know what other things are funded and what it's being worked on to transition to operations. So just go to NESDIS OCS Product Management branch and go from there.
Okay, so I want to highlight an issue that I think we are all struggling with. So within my modest agency, NESDIS, we don't know each other, and we don't know how to get in touch with each other. We don't know how to highlight our successes. We don't know how to vet our successes across agencies when we make a big deal out of them, right? NASA J. So we're talking a lot about using technology to do things, coordinate things, but the people part of that too, that kind of, maybe there's a technological solution, but there are other solutions we need to be thinking about in terms of the culture and the ability to have communications, right? When we say silos, we often mean hierarchies. You have to go up all the way to the roof and then fall through the skylight into somebody else's silo in order to share a cool thing that you did. So I want to share that with it is a universal problem. And with the agencies here, with the other organizations here, somebody's got to be doing it well, and just tell us what you're doing and we'll do that too.
Hi, Ted Haberman from Metadata Game Changers. I appreciated these talks, but what Brian said, I think it was Brian, about knowledge graphs was interesting to me. I was curious how many people in the room are familiar with OpenAlex. Put your hands up higher. Yeah. Okay. Because you were talking about creating knowledge graphs, and OpenAlex is a knowledge graph, which is open. It used to be the Alexandria Digital Library back in the day.
Okay.
And the nice thing about it is if you identify things well in DataSite that John, I guess, has the group that's doing that, maybe an NCEI, and then you connect things in DataSite with related identifiers, then they automatically show up in this graph.
Oh,
And right now, OpenAlex Graph has something like 480 million things in it. So in terms of the value of your connections that you're making there, they go up. And it also has Crossref, so it has all of the scientific literature in it as well that might be related to your data sets as either results that came from those data sets. And they're also doing a lot of work right now on adding funder metadata consistently throughout OpenAlex. So funders like NOAA and different parts of NOAA or NASA or NSF or NIH or whoever, Sloan or Moore or whoever, those funders also get connected in. So then that provides a connection of those funders and a way to demonstrate their impact.
Yeah.
So using DataCite effectively gets all of this for you automatically. And it might be an interesting thing and a useful thing for people in NOAA to be more familiar with.
Yeah, thank you for that. We are planning on, right, we don't want to reinvent the wheel. There are so many unique identifier tools out there that are already being leveraged. So we have already talked with other data sets that we're looking to connect with by leveraging DOIs as a way to sort of a lightweight way to connect that. So to know that there's another tool that we could point those connections to provide even more value is incredible. So thank you very much for that. Yeah. Fantastic. Thank you.
I just wanted to mention the OIS knowledge graph has many persistent identifiers, not just DOI, but other persistent identifiers that you can connect your information with.
Investments are often scientific. Oh, yeah. These investments are often scientific instruments generating data. So they get PIDs. Can we build a database? Is there a federal instrument database? What? I mean, well, okay, so like everything else, we should all be using DataCite and we should be using a schema for the instruments, and we should be doing really rich things. We should also be doing raids. Oh my goodness. We should be doing a whole host. So I'm looking at Joe. There's a whole bunch of different PIDs things we should be. No, I don't think that there's a federal, even within NOAA, is there an instrument database for NOAA? Not a database. There's a list, but it's not a database. Right. Yeah.
A big capital investment observing systems tools. It's not everything that exists across the agency.
So we are out of time. We're going to take one more question. Okay. But also, so Angela, we have some swag up here. On your way out, please grab something cool and some more donuts. Okay. And so we have one more question and that'll roll us out.
Hi, Corey Levinson. I work with an organization called Carbon to Sea doing metadata standards for ocean carbon removal field trials. And a lot of the projects that we work with, some of them are American, some of them are international. We're looking a lot at BODC and like the NERC vocab server. And I'm curious, like within the larger NOAA group, especially with this question about instrument registries and stuff, I'm curious to hear about NOAA's understanding of that relationship to things like NERC vocab server and projects like that.
Okay, so
I'm going to take that.
Oh.
Yeah, John Ralph, NCEI. We are trying to make sure that our tools can accommodate multiple vocabularies so that we can correlate not just BODC, NERC, ICs, but also our internal vocabularies, GCMD, et cetera, so that we can document our data sets as flexibly and as completely, ideally, as possible. That said, of course, that all takes work, and we only have so much budget, time, resources, people, et cetera. So get what you get.
Hey, you want to take us out, John?
Yes. And so with that, I'll say thank you, everybody, for attending today. We hope you learned something and had some fun and got a donut.